Here we're going to get a bit more practice with reaction mechanisms and seeing how these work. So please turn to this page in your packet. It's towards the end. The reaction between nitrogen monoxide and hydrogen is believed to occur in the following three-step process. Notice we got a slow step here in the middle, which would be our rate determining step. We need to write a balanced equation for the overall reaction. Okay, so this is like a Hess's law application. We want to add these up and see what we have at the end. So let's look at all of the reactants and all of the products. Are there some things that would cancel out? The dinitrogen dioxide is on both sides. What else? Dinitrogen monoxide is on both sides. And that looks to be it. So we've got two, this is for letter A, we've got two nitrogen monoxides and two hydrogen molecules, yields one nitrogen molecule and two water molecules. Just ensure that that's balanced. Two nitrogens on this side, two over here, two oxygens here, four hydrogens, okay? So that's our overall reaction. And they did say it's a reaction between nitrogen monoxide and hydrogen. So we've got those two substances here. Okay, B, identify the intermediates. Okay, so let's get rid of all this junk that I crossed out. Okay, intermediates are things that are generated as products but then get consumed later on. So this dinitrogen dioxide gets generated here in the first step and then it reacts away in the second step. So that would be one of the intermediates for sure. Dinitrogen dioxide. And what else? Here's some dinitrogen monoxide generating in that step, getting consumed in the next step. So that is also an intermediate. Okay? And in this particular mechanism, everything that canceled out from earlier, those very things, are the intermediates. Okay, let's look at number 2, the ozone layer. Sorry about that. Boom, down toward the end. Come on. The ozone layer in the Earth's upper atmosphere is important in shielding the Earth from very harmful ultraviolet radiation. Ozone, O3, decomposes according to the equation 2O3 yields 3O2. The mechanism of the reaction is thought to proceed in an initial fast equilibrium and a slow second step. Okay, so this first equilibrium step, this is a unimolecular step. Ozone actually absorbs light from the sun and then breaks apart in this manner, and we get a diatomic oxygen and a single monoatomic oxygen. That's an oxygen atom without an octet. It's very reactive, and it goes on and reacts again with the ozone and generates the more familiar diatomic oxygen. So what's the molecularity of each step? I just mentioned the first step. Okay, first step, step 1, is unimolecular. And step 2, it's just simply counting up how many molecules we've got. Step 2 is bimolecular. Okay. Which of the steps is the rate determining step? It's the slow step, step 2. I don't need a colon there. In parentheses, I'll just say it's the slow step. Okay. Write the rate law for the rate determining step. Okay. Well, these are all elementary reactions, elementary steps. And so the rate law can be determined from the molecularity directly. So step 2, its rate law would simply be rate equals K, okay, O3 concentration, and the O concentration. Each one raised to the first power. Okay. And that's it for number 2. On to the next page. Nitric oxide in the lower atmosphere, the troposphere, can actually cause the synthesis of more ozone. Consider the following series of reactions below. Write the overall reaction. Identify any intermediates and homogeneous catalysts. I'd like for you to pause the video right now. Try to answer these questions, and then after you work a little bit, you can check your answers. Go ahead and pause the video now. Okay, so let's work through these together. We're going to write the overall reaction. So what are the things that are going to be canceling out in a mechanism? It's going to be the catalysts, if there are any, and the intermediates. Okay, so nitrogen dioxide canceling out, monoatomic oxygen canceling out, and that appears to be it. Okay, so we've got, oh no, and then the NO as well. The NO is canceling out, right? And so this is generating ozone. Here we have, let's see, 3/2 O2 yields an O3. That's the overall reaction. Okay, so diatomic oxygen turning into triatomic oxygen, ozone. Okay, so let's go back and see what we're crossing out. Intermediates are things that get formed and then react away. Okay, so the NO2 is forming and then reacting away, as is monoatomic oxygen. Okay, so we are identifying the intermediates, things that get formed and then react away. So our intermediates, these are nitrogen dioxide and monoatomic oxygen. Homogeneous catalysts. The homogeneous catalysts, that's the other things that you need in a sense to react. You got to have them to start with, at least for this particular mechanism you need them. But then they get formed again. So their concentration never really changes over time. And that was everything. So those are our homogeneous catalysts. Just that. See how it says nitric oxide can cause synthesis of more ozone. Okay, so at the end of the day, we're just talking about diatomic oxygen turning into ozone, but it wouldn't really happen to the degree that it does without this catalyst. The catalyst creates a new pathway. This mechanism is in a sense powered by nitrogen monoxide. Describe the difference between homogeneous and a heterogeneous catalyst, and describe the two things that a catalyst causes, which works to increase the rate of a reaction. Okay, so homogeneous catalysts are reactants, and I'll put that in quotes, in the same phase as the other reactants, but they get regenerated. Later in the mechanism. And so aren't true reactants. Okay, and a heterogeneous catalyst is in a different phase than the reactants are. It's often a solid. And what do they both do? All catalysts lower the activation energy of a reaction by generating or by creating a new pathway for the reaction to proceed. Okay, that's it for today. I would like you to go on and finish up the week by answering this free response question. I want you to print off this page or write your answers clearly on a tablet. Label A, B, C, and D so it's easy to locate your responses. As your teacher, I need to be able to know where to look for the response for each thing. So try to communicate clearly in how you write that out. And then please submit it online by Friday afternoon, before midnight really, on the appropriate spot on Portal. I know that we said we're going to switch entirely to AP Classroom, but since this is in the packet already, I'd like for you to submit this one on Portal just as an upload. And so I'll give you up to 10 possible submission pages, but all you should really need is maybe 1 or 2 pages to write out your solutions. Okay,